In recent years, robotics in retail has gained a lot of attention due to involvement of labor-intensive and repetitive tasks which can be automated easily. Many companies like Amazon, Walmart, and Target are testing prototypes of such a robotic system in their warehouses. In this paper, we discuss a work-in-progress approach for enabling power on-and-go robots in retail environments through multimodal techniques. In particular, we use a combination of low-cost hardware sensors such as molecular vision and PLE sensors in conjunction with machine learning techniques to generate high-quality information of environment. Various systems overall architecture. Basically, modalities like depth prediction network is fused with PLE positioning system to obtain high-level information. All the processing is done by onboard computer of mobile base. Let's discuss first modality, molecular depth prediction. Depth prediction network is derived from previous work of Ibrahim El-Hassan. Network architecture consists of encoder-decoder part with connection between layers. However, the original size of the network is too heavy to get decent inference frequency on onboard compute platform of mobile base. Thus, custom encoder part is designed with reduced number of convolutional filters. This decreased network size, which results in faster inference at approximately 9 Hz with 91% overall accuracy on test case. Now let's discuss Ple localization modality. Due to low energy sensors are low cost and have long battery life up to 2 years. Here we deduce the relative distance of Ple sensors using its signal strength. This distance then used to pinpoint location of robot via triangulation between sensor distances and robot. Furthermore, the robot is localized at 10 Hz frequency. Now by fusing this information with odometry, you obtain reliable positioning information of robot. Now let's look at the results from depth prediction network. Here, predicted depth maps are then used to obtain the point clouds. Basically, the obtained point clouds are combined with the positioning information of robot to obtain this 3D map of the environment. Thus, this successfully showcases the use of passive sensing to obtain high-level information of the environment for power on-and-go robotic system in retail. Thank you for watching this video. Please send questions to following email address shown in boldface letter.